Hello 3D printing friends, it's time once again for another Mod Mondays video on the BV3D channel. Today we're going to be installing OctoPrint on a Raspberry Pi 3 Model B Plus, and we're going to be doing it from a Mac. Stick around and we'll get into it right after this. I'm Brian and you are watching BV3D. Hi, welcome back. Now, before we get going, I wanted to say thanks to all of you who subscribe to the channel. I really appreciate you. But if you haven't subscribed yet, please do. It's easy. Just click the subscribe button down there and also click that little bell to get notified when I release new stuff. Okay, so I have a video covering this very subject from about a year ago, but I wanted to make sure that I was providing you with the latest, most accurate information. This is a revised and streamlined version of that video, so it should get you up and running a little more quickly. OctoPrint is a seriously useful web-enabled print server for 3D printers. It's ideally suited to run on the tiny, single-board Raspberry Pi computers. And OctoPi is the super easy way to get it installed and set up on a Raspberry Pi because it has everything pretty much ready to go right out of the box. Now let's talk for a minute about why you might want to run an OctoPrint server. There are a number of good reasons, such as saving time. When you're ready to print, you won't need to go to the printer, pull the memory card, bring it back to the computer, copy a G-code file to it, eject the card from the computer, take it back to the printer, plug it in, and navigate the printer's menus to start the print. Instead, you can drag the G-code file from your desktop into OctoPrint and then click the print button. It really is that easy. You can create folders in OctoPrint to store your files by project or by filament type or what have you, making it easier to reprint things later. For instance, you might have some 3D prints for sale. Maybe you have a particularly popular coaster design, and you can print them easily on demand. You look in your coasters folder and click print on the one you need. You can see your nozzle and heated bed temperatures graphed in real time, which is useful if you think you're having an issue with the printer. If you notice that the temperatures seem to form a rather dramatic sine wave instead of a relatively flat line, it may indicate that you need to perform a PID tuning on your printer. You can add a webcam and monitor your printer's progress from another room. And you can print directly from Cura or Slice or PE. Both of these slicers allow you to add an OctoPrint instance so you can slice and print all from the same app. Now, for the most part, everything that we do here today is going to be point and click stuff, but when it comes time to change the default password on the Raspberry Pi, we're going to use the macOS terminal utility. That's the text-only command line interface for macOS. But there's no need to worry. If you follow along carefully, it'll be a breeze. Okay, so let's go over the hardware and software necessary to get you up and running with OctoPrint. Oh, and links for everything are in this video's description. You will need the following hardware: a Raspberry Pi single-board computer such as the Raspberry Pi 3 Model B Plus, a micro SD card with a capacity of at least 32 gigabytes, a 5-volt 3-amp power adapter with a micro USB plug, a Raspberry Pi case either purchased or 3D printed, and a USB cable to connect the Pi to the printer. Now, the exact type will depend on the kind of USB port that your printer has. You will also need the following software: the OctoPi disk image. This contains both the operating system and the OctoPrint software pre-configured to run on a Raspberry Pi. And you'll need Balena Etcher. You'll use this to write the OctoPi disk image to your micro SD card for the Raspberry Pi. Now let's go over to the computer and get the software ready. First, let's download OctoPi. Open a web browser and go to https://octoprint.org/download. Scroll down just a bit, then click the Download OctoPi button. This will take a moment or two to download. Once the download is finished, check your Downloads folder. If your browser automatically unzipped the file for you, great. If not, you'll need to unzip it yourself. Next, let's download Balena Etcher. In your web browser, go to https://www.balena.io/etcher. Once there, click the Download for macOS button. Once it's done, check your Downloads folder. If your browser automatically unzipped the download for you, you will see the Balena Etcher disk image. If not, you'll need to unzip it yourself. Once you have the disk image available, click it and open it. Then drag the Balena Etcher icon to Applications to install it. If you're prompted for administrator credentials, provide them. And now Etcher is installed, and we can close the browser window. Now we can get the hardware ready. Install the Raspberry Pi 3 Model B Plus single board computer into a case. The exact procedure for this will vary by case design. Some cases snap together, others are held together by screws. Follow the instructions which came with your case to get it assembled. The case should allow for access to the microSD card slot. Okay, we have our hardware and software ducks in a row, so now it's time to get this installation party started. Ready? Let's go. Now you'll need to insert the microSD card into your Mac. Not all Macs have SD card slots. iMac and Mac Mini computers do, as do some but not all MacBook and MacBook Pro computers. And none have microSD card slots. So you may need to use a microSD to SD card adapter, such as the one that came with the card that I've linked, or you may need to use a USB card reader. Once inserted, the card's icon should appear on the desktop. Next, launch Balena Etcher. In the Finder, click the Go menu, then click Applications. In the Applications window, double-click the Balena Etcher icon. In Etcher, click the Select Image button. Navigate to your Downloads folder, and select the OctoPi image that you downloaded earlier. Balena Etcher should automatically select the SD card. If it didn't, you'll need to click here and select it manually. Click the Flash button. You may be prompted for administrator credentials, and if you are, provide them. Then wait while Etcher flashes and then validates the OctoPi image on the SD card. When Etcher finishes, it will automatically eject the SD card. Quit Etcher. Now, because Etcher automatically ejected the microSD card, we need to remove it and then reinsert it into the Mac. A disk icon named Boot should appear on the desktop. If you don't see it, do this. In the Finder, click the Go menu, then click Computer. This opens a window showing all of the available disks on the computer. Open the boot icon, then locate and double-click the OctoPi-WPA-supplicant text file. Down here in the WPA/WPA2 secured section, this is where we will insert our network information. First, remove the pound signs from the beginning of these lines to uncomment them. Then in the SSID line where it says put SSID here, this is where you will type in the name of your Wi-Fi network. Mine is Atlantis. In the PSK or pre-shared key line, this is where you will type your password. This is the password for your Wi-Fi network. With that done, close and save the file. Eject the SD card from your computer. Insert the microSD card into the Raspberry Pi, then apply power to the Raspberry Pi. Be patient, the first boot will take a few moments. After the Pi boots, you should be able to connect to it in a web browser. Open a browser and go to http://octopi.local. And there you go. You've got OctoPi installed on a Raspberry Pi. Now there will be a little bit of configuration necessary, so we'll go through that now. On the Setup Wizard on the Hello screen, go ahead and click Next. Next is the Access Control screen. If you intend to run your OctoPrint server in such a way that you can reach it from the public internet, you will want to enable this by requiring a username and password on your OctoPrint server. Even if you don't intend to run your OctoPrint server where it's visible from the public internet, you may still want to require a username and password if you're operating on a shared private network. Perhaps you have roommates or guests and you don't want them to be able to interfere with your printer. In that instance, you would still want to require a username and password. We'll go ahead and fill this out now. So type a username and a password, also confirm the password, then click Keep Access Control Enabled. With that done, click the Next button. Next is configuring anonymous usage tracking. The OctoPrint developers want to see what versions of OctoPrint are running out there and whether they are successful in completing print jobs and such like that. I don't mind that being shared, so I'm going to click Enable Anonymous Usage Tracking. If you don't want that, you can click Disable. But I will click Enable, and then I will click Next. Next, we're configuring the connectivity check, and this is just where OctoPrint can go and check against a DNS server to make sure it can talk to the internet. I will enable the connectivity check, and then I will click Next. You will probably want to enable plugin blacklist processing. This prevents you from accidentally installing plugins that will have problems with this version of OctoPrint. So I will enable that and click Next. Next is setting up a slicing profile. OctoPrint includes an older version of the Cura slicing engine. I'm not intending to use this, so I'm not going to set up a profile. I'm just going to click Next. Now we're just setting up some basic information about the printer that OctoPrint is going to be controlling. So we'll give this a name. This will be my A8, and I will be more specific about its model here. We'll switch to the print bed and build volume. This is a rectangular bed. The origin is in the lower left. It has a heated bed. The print volume on the A8 is 220 on the X, 220 on the Y, and 240 on the Z. We'll set those values, check axes. The information in the axes tab is fine. The information in the hot end and extruder tab is fine. So we'll click Next. Now that we're done, we can click Finish. And we are done setting up OctoPrint. Next, connect a USB cable from the Raspberry Pi to the printer's USB port. Then turn the printer on. Once the printer is powered up, click Connect. If everything went well, OctoPrint is now communicating with your printer. Oh, there's one more thing we need to do, and that's change the password on the Raspberry Pi itself. Let's do that real quick. This will require us to use the macOS Terminal utility, so in the Finder, click the Go menu, then click Utilities. In the Utilities folder, locate and double-click the Terminal application. Our Raspberry Pi is on our network as OctoPi.local. It has a single administrator account named Pi. This is separate from the username and password that you may have set up earlier in OctoPrint's access control screen. In Terminal, to log into the Raspberry Pi, we're going to use the SSH or Secure Shell command. Begin by typing SSH, and then a space. Follow that with the username, Pi, an @sign, and then the Raspberry Pi's network name, OctoPi.local. Then press Return. The first time you connect to it, Terminal shows some security information and asks if you want to continue connecting. Type Yes, and then press Return. Terminal will remember this for future connections. You'll be prompted for the password to log into the account, and the default password is Raspberry, all in lowercase. So type RASPBERRY, and then press Return. If all goes well, you'll be looking at a screen with more text, and that's fine, this is expected. So to change the password for this Pi account that we're logged into, we'll use the password command. That's PASSWD, all lowercase. So type that in and press Return. You'll be prompted for the old password, which is Raspberry, so type that in and press Return. Then you'll be prompted for the new password, and this is where you set what you want the new password to be. Don't forget this password. So whatever you want it to be, type that in and press Return. You'll be asked to type it again, just to make sure that you've got it keyed in right, so do that and press Return again. If you typed your new password correctly both times, then it will tell you that the password was updated successfully. Okay, so now we're done. We can quit the Terminal utility. You now have an operational OctoPrint server running on a Raspberry Pi connected to your 3D printer by a USB cable. And so now, what's left? Maybe we should print something? Well, here's our OctoPrint instance, and I also have a G-code file that I sliced earlier. We'll take this and drag it over here to OctoPrint. And then we'll start it printing. Well, that was easy. I mean, all of it was pretty easy. We downloaded the OctoPrint disk image and flashed it to a micro SD card. We added our Wi-Fi network information, and we got the Raspberry Pi running on our network. Then we told OctoPrint about our printer, mostly just telling it about the print volume, and we changed the default password to protect the admin account on the Raspberry Pi. And that puts us right at the end of this episode, and I do hope you found this video useful. If you liked the video, please give it a thumbs up. If you didn't, give it a thumbs down, but either way, share your thoughts in the comments. If you like the content that I'm producing and you'd like to help out, consider supporting the channel with a one-time micropayment. You could buy me a coffee or leave a little something in the PayPal tip jar. Links for both are in the description. Well, alright, now that I've got an OctoPrint server set up, I'm going to go print something cool without having to run back and forth to the printer to get it started. You go print something cool too, and I'll see you next time.